Hey everyone, a very warm welcome back to the channel. Today we are discussing the question number 20 from the chapter of trigonometry. The question is asking us to evaluate the value of 4 sine 2 pi by 7 minus tan pi by 7. The maximum time allotted for this question would be 9 minutes, and ideally you should try to do it within 4 minutes. So I hope you all have tried it out. Now the answer to this question would be under root 7, and the concepts and formulas used are going to be the formula of tan of n theta. We should know how to expand just this formula. We should be able to remember, and sine 2 theta is equal to 2 tan theta upon 1 plus tan square theta. This formula also we should know. Now let's see the actual solution. So let us say we take theta is equal to pi by 7, because pi by 7 is present in the given question. So we basically wish to find 4 sine to theta minus tan theta, but sine to theta, of course, we can write in terms of tan theta, and we have let small t is equal to tan theta. So on taking the LCM and simplifying, this is the expression that we wish to find. Now what we can do is that obviously this is kind of a a rational or algebraic expression in t. So we might wish to form some equation in t, which is obviously going to be a polynomial equation. So how to do that? So that's what we are trying to do. So theta equal to pi by 7 would mean 7 theta equal to pi, and that would mean tan of 7 theta would be equal to 0. Now, since tan of 7 theta can be expanded in terms of tan theta, we have done just that using the formula that we just saw. Now what we are able to do is that we are able to put small t equal to tan theta, and denominator gets cancelled. So the numerator comes out to be this quantity, where small t stands for tan theta. Now the thing is that t obviously is not equal to 0, because tan of theta, where theta is pi by 7, cannot be 0. So we can easily cancel by small t, and this is the expression that we are getting. Now the thing is that we are able to observe that this is clearly a polynomial equation with degree 6. So what we can do is, in order to find this, it makes sense that we might have to form a perfect square, because here the degree is 3 and we have got an equation with the degree 6. So we are going to try to form an equation with the square of this quantity. So the way we form the square is, t power 6 is already there. Then we are going to need 49 t square. So in the very next step, we have done just that. We have added 14 t square to both the sides, so that 35 plus 14 would give us 49 t square. And apart from that, minus 14 t cube would have to come, or minus 14 t power 4 would have to come. So what we have done is we have added 7 t power 4 to both the sides. So minus 21 plus 7 would yield minus 14 t power 4. So it's basically in this way that we have been able to form 70 minus t cube whole square on the left hand side. But when we take out 7 as common from the right hand side, we are going to get 1 plus t square whole square. And that is exactly what we had actually needed. So the question now becomes very simple. We just divide and take the under root, so that the value of the expression e we get as plus or minus root 7. But it is very obvious to note that pi by 7 is less than pi by 4, and it is obviously greater than 0. So we can say that tan of pi by 4 would lie from 0 to 1, or tan of pi by 7 would lie from 0 to 1. So what we can do is, this expression can be written as t into 7 minus t square upon 1 plus t square. So clearly this is greater than 0, because t is greater than 0. And since t lies from 0 to 1, its square would also lie from 0 to 1. So 7 minus that thing would obviously be positive. So clearly the expression e needs to be positive. And hence the value positive root 7 is accepted as the final answer. So a little easy question, I mean not lengthy, but a little tricky. So I hope you were able to understand and follow through the explanation. Make sure you like the video, comment down below what more you would like to see next, share it with your friends, subscribe to the channel, and I'll see you all in the next one.